so let's now give this problem a little reading. We have opened here the problem 238, product of array except self. First of all, we're gonna give it some reading for us to better understand the situation of this problem. So, given an array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. So, all right, let's keep reading. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. All right. You must write an algorithm that runs in big O of n time and without using the division operation. Here you have some examples. So, what we understand here, we have an integer array nums. This array has different elements, and we have to create an output array or an answer array that will be actually, once we have the index I, it will have the product of all elements of the array except that one. So if we think this through, if we go to index 0 right here, which is 1, we will have 2 times 3, 12, 2 times 3, 6, times 4, 24. So that's why we have 24 here. If we go to the next one, index 1, it will be 1 times 3, which is 3, and 3 times 4, which is 12. So we already understand what the output array or the answer array has to have inside of it. The length of the array will be 2 at least till 10 to the power of 5. So we will have at least 2 elements in this array. And the values in this array will be from minus 30 till positive 30. We also see that the input is generated such that answer I is guaranteed to fit in a 32-bit integer. Follow up. Can you solve the problem in big O of 1 extra space complexity? The output does not count as extra space for space complexity analysis. All right, so we have here 2 constraints, 3 actually, if we take the follow-up as well into consideration when we are going to give the final answer. The first one has to run in big O of n time, and we are not allowed to use division operation. And we have to solve this problem in big O of 1 extra space complexity. So let's gain some deeper thought in this problem and see how we can solve this. Awesome. So once we think about solving this problem, we initially think on something really simple, which would be just multiplying or getting the product of all elements of the array. So after we had the product here, so 1 times 2, 2, 2 times 3, 6, 6 times 4, 24. So after we had this, the only thing we needed to do was to get this value, then divide it by the position, the corresponding position of the input array, and put that value here in the output array. So if we had 24 divided by 1, here we would have 24, for example. But we are not allowed to use a division operation, which is kind of what gives the complexity of this question, right? So we will go through another way to solve this, which will be using prefix and postfix. How does it work? So once we get to that one element, we know the result we want. It will be the multiplication of all products that comes, all products that come before. I mean, the product of all prefixes, all numbers that came before that one element, multiplied by the product of all elements that come after. So if we have this multiplication between these products, between these elements and in this element, we will find the answer or the value for that specific index, right? So if what we can do initially, we will get two arrays. One array will be prefix and then the other one will be postfix. And we will start multiplying everything that comes before that specific index. For example, we want to have the product of everything that comes before index 1. So if we look at this, we will say that what comes before is 1. So we put 1 here, right? Because it's 1 times nothing before. Now that we came here, we go to look at the index 0. Since there's nothing before index 0, there's nothing multiplying it. So because of it, we put 1, which is the neutral element of multiplication. And after we do this, we go to the next one, and remember, we insert 1 here because there's nothing before the index 0. So we put 1 here as a default value. Then we go to index 1. Once we go to index 1, what comes before index 1? 1. So we insert 1 here. After that, we go to the next array, the next index 3, which will be 2 times 1, which will be 2. And then we go to index 4, which will be 3 times 2 times 1, or 3 times the last one we have here in the prefix, right? So it will be 3 times 2, which will be 6. So here we have computed the prefix array. After we come to this place, we now go calculate the postfix. Initially, we started computing these values from the left, from index till the end of the array. Now we're gonna do backwards, right? We'll start calculating from the end of the array till the beginning. So once we start calculating the postfix, we have to think: is there anything that comes after the postfix? There's nothing. So we will use also the number 1 here as the neutral element of multiplication. It is a really similar concept that we use in the prefix, since there's nothing before the first element, we put 1. Since there's nothing after the last element, we also put 1. Then we go to the next one. Everything that comes before the index 3, index 2, which has value 3, it will be 4. Everything that comes after as a postfix, after the index 1, which has value 2, which will be 3 times 4, which will be 12. And then at the end, we reach the index 0, and we will have 2 times 3, 6 times 4, which will be 24. So now we have the prefix and the postfix array. And what do we have to do to compute the output? We just have to get the prefix and the postfix multiply, have the product of its matching indexes. So when we have the prefix, everything that comes before the element on index 0, and everything that comes after the index 0. So we multiply them. 1 times 24, 24. Then we keep doing the same. 1 times 12, 12. 2 times 4, 8. and 1 times 6, 6. So this way we were able to calculate the answer array or the results array or the output array using the prefix and postfix strategy. But remember, once we were reading the problem, we saw that we could find a way in the follow-up section of the problem that we could only have big O of 1 space complexity. And for that, it is said that the output array or the answer array does not count in the space complexity analysis. So what can we do? Instead of using a prefix and postfix arrays, we will first populate the output array with the prefixes. And after we populate it with the prefixes, once we calculate the postfixes, instead of allocating those values in a postfix array, we will put these values already in the output array. But not only give the value, but we will insert that value there, multiplying. We will multiply the postfix value already with whatever value is inside that one position of the array, because we know that there we already have the prefix value. So after we do this, we will iterate over the output array and over the input array twice. One, calculating the prefixes and attributing the prefixes at the output, and one, calculating the postfixes and putting these values inside each position of our array, already computing the final value. So now that we have discussed this a little further, let's jump into the code. Awesome. So now we're back to our LeetCode tab, and let's start the fun coding, right? So before we start, let's just put some comments here to guide us through our process. So the very first thing, we have to create the array, then we calculate and give values to the answer array, then we calculate and give values to answer array, answer. So here we calculate the prefixes, and here we calculate the postfixes. So this way we're able to visualize exactly what we will be doing each time of the work, so we can kind of better organize our thoughts. Once we create the array, let us think we will create an int array. We will call it, let's call it results. It will be equals in new int, and for the length we can actually just store this in a variable here. Let's call it n, which will be equals nums dot length. Let's put n here. So the output array will have the same size of the input array, so that's why we do this. Once we now start calculating the prefixes, let's now have a for here for int I starting from 0. And now remember, we actually know for a fact that there's nothing before 0. So at this element, so results at 0, we will give the value 1. Since there's nothing before this position, there's nothing to compute there. So we will start at position 1, index 1 in our array, because we already gave a default value to the results array in position 0 and at index 0. Then I less greater than n, which is the length of our array, I plus plus. So results I will receive results I minus 1 multiplied by nums multiplied by nums I minus 1. So this way we are going to be able to compute each prefix. So for the prefixes, that's what we have for it. That's how we compute it. Then we will create another 4. This one, in this case, will be equals n minus 1, because now we are coming from the end of our array till the beginning, right? I greater equals to 0, and now we're coming from the right to the left. Minus. So remember, we already have the prefixes stored in our results array, our output array. So for us to do this, we have to keep the data of the postfixes somewhere else. For that, we can just create an int, we can call it postfix, and give the value 1. Remember, there's nothing after the last index position in our array, so we give the default value of 1. Then we can start calculating by this. So results I, so our last position in our array, will be multiplied by itself in postfix. After we do this computation, we have then to update postfix, calculating with the next value. So it will be postfix, which is equals 1, multiply it by multiplying itself with nums I. So this way we are able to calculate each postfix, and at each iteration we will be able to insert that multiplication, make that product between the postfix and that specific element in our specific index position. So after we finish this computation, we will have inserted and multiplied already every single element that we were thinking. So after we finish this, the only thing we have to do is return results. Let us see if everything is all right here. All right, so everything looks all right with our solution. So let's then submit. Awesome. So we were able to accomplish the given task. We were able to do it in the n time complexity. We are not using the division operation, and we are also using big O of 1 space complexity, because The only array we are using is results, which is the output array. And as it is stated in the problem, the output array is not counted in the time space complexity. So we were able to achieve our goal to answer this question according to the guidelines of the problem. So this was my very first video in my LeetCode series where I share my line of thought on how I go, my thinking process to solve a problem. Please feel free to reach out back to me. You're able to get the link in my portfolio, or you can drop a comment in the comment section below. And I will be back bringing more content, not only about LeetCode, but also about software engineering principles, software architecture, Java, Spring, and many other nice concepts and subjects that are really interesting for us in the tech world. Thank you very much. Bye-bye.